All right, this lesson is about arithmetic series. So I want to start off by talking about sequences, which is what we were doing in the last lesson. So we had a sequence, say 3, 5, 7, 9, etc. And there were a couple of different ways that we could write a formula for this sequence. One way would be an explicit formula, which would be to say that the nth term in a sequence is equal to, and we had a formula for this, but the way that I like to do this is I think about this as being like our formula for a straight line, y equals mx plus b. So where m is the rate of change and b is the y-intercept. Well, here our m, our rate of change, is what's the difference between each of these terms in the sequence. So here the common difference is 2. So we're going to be 2 times n plus our y-intercept. So in this case, that would be our 0th term, the term right before the first term. If we continued this pattern backwards, we're adding 2 each time. So if we continued it backwards, we'd have to subtract 2 to get there, and that would be 1. So 2n plus 1 is going to be the formula for this arithmetic sequence, the explicit formula. And then to find the recursive formula, we're first going to say, so this is explicit, and the recursive would be, we'd first say the first term is going to be equal to 3. That's how we always start our recursive formulas, is just by saying what the first term is. And then all future terms, so a sub n, is going to be equal to the previous term, a sub n minus 1, plus the common difference. So here we're adding 2. Plus 9. And now, if we just say plus all the way up to infinity, well, that's not going to be very useful to us, because obviously if we just keep adding more terms to this, it's just going to go to infinity. It's going to keep growing forever. And so we're not going to come to a certain number. For some series, you can add to infinity and get a 201. So now we've got this series here, 3 plus 5 plus 7 plus 9 plus 11 plus all the way up. And let's add a few terms here. Let's say 195, 197, 199, 201. All right, so let me make sure that this all fits on the board here. So we got 3 plus 5 plus 7 plus 9 plus ... 195 plus 197 plus 199. Find this sum. Well, one way would just be to just start at the beginning and keep adding. So we do 3 plus 5 is 8, 8 plus 7 is 15, 15 plus 9 is 24, and keep doing it like that. But that would get tedious and would take a while. Is to notice that 3 plus 201 is 204. And 5 plus 199 is also 204. And 7 plus 197 is is 204, and 9 plus 195 is 200. If we knew how many pairs we would get, we could just multiply the number of pairs by 204, and that would be our sum. So how do we figure out how many pairs there are in that sequence? Well, there's two terms in every one of the pairs. So if we figured out how many terms there are in this, so we said before that the formula, the explicit formula for the sequence was 2n plus 1. Let's set that equal to 201, and that'll tell us which term in the sequence this is. So if we set that equal to 201 and subtract 1 from both, n is equal to 100. So there's 100 terms in this sequence. Excuse me. Which means that there's 50 pairs of terms that we're multiplying by 200. So the sum of this sequence is 204, which is 10,200. And so that's a quick and easy way to sum all the terms in an arithmetic series. All right. Now let's do the two examples up here. So that the sum of a series with n terms is equal to n divided by 2 times the first term in the series plus the last term in the series. So S of n equals n over 2 times a sub 1 plus a sub n. All right. So our first example was we had negative 5 plus 9 plus all the way up to 317. So to do this, our sum is going to be equal to n divided by 2. We don't know what our n is yet, but it's going to be equal to negative 5 plus 317. So let's figure out what that n is. We know it's going to be divided by 2. But to figure out the n, explicit formula for this. And that's going to be, let's see, a sub n is going to be equal to, well, we're adding 7 each time, so 7n. And then the 0th term, if we subtracted 7, then back to here we'd get minus 12. So 7n minus 12 is the explicit formula for this series. And let's set this last term equal. And now we can solve for n by adding 12 to both sides. It's 7n is equal to 329. Divide both sides by 7. And we get that n is equal to 47. So we can plug that in up here. So our sum is equal to 47 divided by 2. Negative 5 plus 317. So 47 over 2 times 312. 312 divided by 2 is 156 times 47 is going to be 7,332. So there's our answer for the first example. Next one, we've got this capital sigma, and down below we've got n equals 1. Up here we've got 75, and then 3n minus 10. So let's talk about this symbol here. This capital sigma means the sum, and it means the sum from the first term up to the 75th term. So here's our explicit formula, and we want the sum of this sequence from the first term up to the 75th term. So that's our series, is this sum. And so let's write out a few of these terms and see what this would look like. So if we plugged in 1 for n, 3 times 1 is 3, minus 10 is negative 7. And then 2, 3 times 2 is 3, plug in 3, 3 times 3 is 9, minus 10 is negative 1. And then 3 times 4 is 12, minus 10 is positive 2. And you can see that we're just adding 3 each time. So this is going to be plus 5, plus. These two are equivalent. This series and this series are the same thing. And now let's find the sum. So the sum of this is going to be equal to n, which we know is first term, which is negative 7, plus our last term, which is 2. So this is 75 divided by 2 times 215 minus 7 is 208. Times 75 is going to be 7,500 plus 300 is 78. So there's our answer for example number 2.